Hello, my name is Marco from the PICUS lab at the University of Naples Federico II in Italy, and I'm going to present you our contribution to the SympTEMIST shared task at the 11th BioCreative workshop at EMEA 2023. Our paper is named Disambiguating Entity Linking Candidates with Question Answering. Let's delve into our methodology. We'll begin with a broad overview before describing its application to the SympTEMIST challenge. Our process starts by taking a textual input that references a specific entity, in our context, a symptom. We embed the entity mentioned within a computational space that allows us to measure its proximity to mentions in the training set and/or the gazetteer. Here, the embedding method is pivotal, as it influences the selection of top candidates. Subsequently, a multiple-choice question-answering model assesses the original sentence alongside the generated candidates. Its objective is to discern the most accurate candidate, utilizing descriptions of each potential concept. Please note that the concept descriptions are not provided with the SympTEMIST corpus, thus we had to retrieve them. In our research, we've harnessed the capabilities of GPT 3.5 to extract concept descriptions. The prompt we used, which you can see here, facilitated the retrieval of short, precise, and relevant information. Okay, let's now explore the application of our method to the SympTEMIST corpus. Please note that for brevity, this discussion focuses only on the second subtrack of the challenge, but the adaptability of our approach allowed for its straightforward application also for the multilingual track, specifically to the Italian corpus. Within the second subtract, we utilize the training set comprising over 3,000 samples from around 300 clinical case reports, encompassing about 1,500 unique concepts. To evaluate the efficacy of our method, we reserved 20% of the training data for validation. However, our approach to creating this internal test set, stratifying data based on concept occurrences frequency, has led us to wrong conclusions. In fact, our stratification criterion caused omitting from the test data all the concepts that appeared only once in the training set. Yet, these single occurrence concepts constitute a substantial portion of the training data, and by not including them into our internal test set, we inadvertently skewed our validation process, which led to less robust validation choices. Our candidate generation method, crafted for this challenge, adopts a straightforward yet effective approach. Basically, we archive the embeddings of all the mentions from the training set and from gazetteer, and during an inference, we identify the k nearest neighbors to the test distance as potential candidates. This is achieved through embeddings computed using two distinct transformer backbones, a RoBERTa model which has been pre-trained on general-purpose Spanish corpora, and a cross-lingual SapBERT model. For the multiple-choice question-answering model, we have fine-tuned the RoBERTa architecture. We evaluated the system's performance by observing the effects of incrementing the number of candidates for each method independently. Interestingly, the SapBERT model's performance showed no significant gains with an increased candidate pool. In contrast, the RoBERTa-based approach demonstrated a positive trend. Its disambiguation accuracy improved progressively with the addition of more candidates, reaching an optimal peak with 7 candidates. At this point, a natural question is, what would be the outcome if we were to integrate candidates generated by both the methods into a single question-answering model? Such an integration would enable us to capitalize on the varied predictions offered by the two distinct backbone models, potentially enriching the robustness of our results. Faced with time constraints, time limitations, extensive experimentations with various configurations was not feasible. However, we strategically selected the most effective single configurations, specifically 1 for SapBERT and 7 for RoBERTa. By combining these candidates, we devised an hybrid solution that surpassed the performance of both in the individual baselines. However, these promising outcomes did not translate to the official test data, unfortunately, due to the wrong splitting choice. Anyway, so, despite the discouraging results obtained with the challenge, we will continue to investigate our approach. There are several margins for improvements. First of all, we can integrate new and more sophisticated candidate generation strategies, maybe stealing them from the winners of this challenge, who knows. Then, we would like to increase the number of merged strategies in the hybrid solution, and we plan to use large language models as backbones for the question answering module due to their enhanced text understanding capabilities. Thank you so much for the attention, and please feel free to reach out to me at my email address. Bye.